Students, good morning. Really, I am so happy to see you once again through this CETEL YouTube channel. Today, I am going to discuss the molecular diffusion, steady state molecular diffusion in fluids. One at rest, one under laminar flow. Both condition, I am going to derive the flux equation. This is the first stepping stone to enter into the mass transfer ocean. Clear? Steady state. Molecular diffusion in fluids at rest and in laminar flow. Laminar flow. Clear? Right. For that, first let us consider a binary solution. Binary solution. Binary means only two components. Binary means only two components A and B present in the solution. Clear? Binary solution. First condition. Second one is the component A moves only in one direction. Assumptions are component A moves only in one direction. Component A moves in only one direction. Clear? Say for example Z direction. Another one is process is under steady state condition. Process is under steady state condition. Steady state condition means there is no changes in concentration with respect to time. Steady state means no changes in concentration with respect to time. Steady state condition. I am not saying with respect to location. I am going to discuss only about the changes in concentration with respect to location. Changes in concentration with respect to time. No. Clear? Right. Steady state condition. Third one is flux NA and NB are constant. Assume that flux NA and NB are constant. Moreover, diffusive mobility or diffusion coefficient is assumed to be constant. Under this circumstance, I am going to write the fixed first law of diffusion. Fixed first law of diffusion. Fixed first law of diffusion. That means JA is equal to minus of DAB into dou CA divided by dou Z. JA means flux of component A. Flux of component A with respect to average molar velocity of all the components in the solution. This flux JA is highly useful in predicting the characteristic nature of component A. Flux JA is nothing but it is the characteristic nature of component A in the solution. Clear? JA. Minus sign indicates decrease in concentration. Decrease in concentration of component A with respect to distance from a region of higher concentration to a region of lower concentration. DAB is nothing but diffusive mobility. Diffusive mobility. It is a measure of diffusive mobility. Diffusivity or diffusion coefficient, it is a measure of diffusive mobility of a component. This is concentration gradient. Concentration gradient means concentration difference with respect to distance. Are you clear? This is concentration gradient. Concentration gradient is nothing but concentration difference with respect to distance. This is the fixed first law of diffusion. Clear? Right. Next, net flux or total flux. Total flux N. N is equal to NA plus NB. I am going to concentrate only about flux of A. Clear? This is made up of two parts. This is made up of two parts. First part, the product of total flux, that means bulk motion, and fraction of XA, that is N into XA. This is called as bulk motion. This is mole fraction of A in the solution. It gives flux of A alone. Clear? This is the product of total flux, that means bulk motion into its mole fraction. Next one is, another one is flux JA. Flux JA. So, NA is equal to N into XA plus JA. Clear? Where N is nothing but NA plus NB. So, NA is equal to NA plus NB into XA. For solution, mole fraction is the concentration fraction. Mole fraction is equal to concentration fraction. Fraction means individual divided by total. Hence, I am writing Ca by C minus dAB into dou Ca divided by dou Z. Now, I am going to establish a relationship for changes in concentration with respect to distance. Establishment of relationship or expression for changes in concentration. Changes in concentration of A with respect to distance. Clear? For that, I am going to rearrange this equation. For that, I am going to rearrange this equation and integration. Right. What about the integration? Rearrange. Right. So this one, NA minus NA plus NB into Ca divided by C is equal to minus DAB into dou Ca by dou Z. Clear? NA into C minus NA plus NB into Ca whole divided by C. In this term, multiply and divide by C. C will be taken out commonly, hence this equation becomes NA into C minus of NA plus NB into Ca divided by C is equal to minus of DAB into dou Ca divided by dou Z. Now I am going to integrate this equation. That means 1 by DAB into C into dZ. This DAB comes under this equation and dZ will be in the denominator. Clear? Again, minus 1 divided by NAC minus of NA plus NB into Ca into dCA. Integration from limits Z1 to Z2, Ca1 to Ca2. That means I am going to establish the relationship for changes in concentration with respect to distance from the concentration range Ca1 to Ca2, similarly Z1 to Z2. On integration, this equation becomes Z divided by DAB into C is equal to, see this equation. This equation seems to be like this: 1 divided by A minus Bx integral dx x1 to x2. Clear? Mathematically, this equation becomes minus 1 by minus b into ln into A minus Bx divided by A minus Bx limit tends to x1 to x2. Apply this formula in this equation. Clear? Minus 1 divided by minus of Na plus Nb into ln NaC minus Na plus Nb into Ca whole divided by Na into C minus Na plus Nb into Ca, limit tends to Ca1 to Ca2. Right clear? This is the mathematical formulation. Method to integrate. Okay, minus minus gets cancelled. Minus minus gets cancelled. The remaining things are Z into DAB into C is equal to 1 divided by Na plus Nb into ln Na into C minus Na plus Nb into Ca2 whole divided by Na into C minus Na plus Nb into Ca1. This is the final formula. Still simplification, multiply by Na on both sides. Multiply Na on both sides. That means Na into Z divided by DAB into C is equal to Na divided by Na plus Nb into ln. Listen, I am going to divide C denominator and numerator. Clear? Hence this equation becomes Na minus Na plus Nb into Ca2 divided by C whole divided by Na minus Na plus Nb into Ca1 by C. Clear? What next? The final format is I am in need of only Na. I am in need of only Na. So the equation becomes Na is equal to Na divided by Na plus Nb. Clear? Next, DAB into C divided by Z. Next, ln Na minus Na plus Nb into Ca2 divided by C whole divided by Na minus Na plus Nb Ca1 minus C. Clear? This is the final equation for flux of A. This equation arrived based on some assumptions. Assumption number 1, we are taking a binary solution. Binary means compounds A and B alone present in the solution. Assumptions: compound A moves only in one direction, say for example Z direction. Flux under steady state condition, the process or calculation under steady state condition, that means changes in concentration with respect to time. No, there is no changes in concentration with respect to time, 0. Next, flux Na and Nb are constant. DAB, diffusivity or diffusion coefficient, which is a measure of diffusive mobility of A in solution. DAB is also constant. These are all the assumptions. Under these assumptions, we arrive this final equation. This is the important equation. What I am trying to say is, this is the first stepping stone which is used to enter into the mass transfer operations. But your real time, when you go for real time process, movement of A not in only one direction. First. Second point there, flux Na and Nb will not be constant. So you have to go for 3-dimensional aspects. This is the fundamental information for molecular diffusion, steady state molecular diffusion in fluids at rest and in laminar flow. Thank you.